Okay, Wile E. Coyote is still trying to catch the Roadrunner. This time he's going to shoot an arrow from the ground up at the Roadrunner, who's on a 200-foot cliff. Okay, he shoots the arrow with the initial velocity of 90 feet per second. So we got a couple questions here. Number one, will the arrow get high enough to reach the Roadrunner? And then, if so, let's assume he misses, then how high will the arrow actually get before it starts to come back down? Okay, we can do this two different ways. Both ways we're going to need to start out with our falling object formula. Okay, so let's remind what the formula is. H equals negative 16t squared plus V0 times t plus H0. Now the first way we're going to do it is by finding the vertex. Okay, that would tell us the highest point. To get the vertex, to get the time it takes to reach the vertex, okay, the formula is negative b over 2a. Okay, so we need our a, b, and c. So in our formula, it's going to be negative 16t squared plus our initial velocity is 90 t. And our initial height is going to be 0 because he's shooting it from ground level. Okay, notice in this method, right now we're not using the fact that the Roadrunner is 200 feet high. So that doesn't figure into our calculation yet. Okay. So if we put in negative b, so that would be negative 90 over 2 times a, so 2 times negative 16. Okay. This will give us negative 90 over negative 32. Which comes out to be about 2.8 seconds. So we know it's going to take this arrow about 2.8 seconds to reach its highest point. Now, what will the highest point be? Well, we plug that back into our formula for the t. So the highest point will be at negative 16 times 2.8 squared plus 90 times 2.8. And that will give us 126.56 feet. Okay, so this actually will answer both questions for us. We got 126.56 feet. So if the Roadrunner is on a 200-foot cliff, well, our arrow's not going to get high enough to hit him. The arrow's only going to get to a height of 126 feet. So, it's not going to reach the Roadrunner, and therefore, it's not going to miss him, but we still know it's only going to go 126.56 feet high. Okay, so that's one way we can do this. We can find the vertex, find the highest point, and then determine if it's going to get high enough to hit the Roadrunner. But let's look at another way we could have done this. Let's go back to our original formula. Okay, so we got a formula relating the time and the height. And now we're going to use the 200 because we know that the Roadrunner is at 200 feet high. So if I put 200 in here for h and solve this formula, this will tell me when the arrow will reach 200 feet. So let's see what that gives us. We'll have 200 equals negative 16t squared plus 90t. Okay. Now this is a quadratic, and to solve this, we're going to use the quadratic formula. But in order to do that, we've got to make one side equal 0. So I'm going to take this 200 and move it over to the other side. So that'll leave me with 0 on the left, negative 16t squared plus 90t, and now this will be minus 200. Okay. So we have our A, B, and C, remembering the negative goes with the 200. So let's use our quadratic formula. So T would be negative 90, negative B, plus or minus. Okay, under the square root, we're going to have b squared. So 90 squared minus 4 times A, which is negative 16, times C, which is negative 200. And then all of this is going to be over 2A. So 2 times negative 16. So the next step is we're going to do some calculating. So we have T equals negative 90 plus or minus. Okay, let me go ahead and do the denominator first. 2 times negative 16, that's negative 32. So if I calculate this here, we've got 90 squared minus 4 times negative 16 times negative 200. So this is going to give me negative 4,700. Okay. And now we can stop because we've got a square root and we've got a negative number under the square root. Well, we can only take the square root of positive numbers. So the fact that we get a negative under the square root tells us that this can't happen. We're going to get an imaginary number. And so what does that mean for our problem? Okay. When will the arrow reach 200 feet? Because that's what we started. Well, it's not going to. That's why we got an imaginary number. It's not going to happen. And so doing it this way, we can see that the arrow won't reach 200 feet, which we also did over here by the vertex formula. So here's two different ways to solve this problem, and both ways give us the same result, that the arrow is not going to get up to 200 feet.